Welcome back. So we've already covered inheritance, but it's worth talking about when we actually want to inherit and how we want to inherit at times. So in general, the way that Python uses inheritance is that let's suppose that we have a superclass. So I'm going to represent classes by this factory. I think a factory is a good metaphor for classes, a factory for constructing instances. So let's say that this red factory represents a superclass. And a superclass is the class that we're inheriting from. Let's suppose that this blue factory represents a subclass. So the subclass inherits from the superclass. I'm going to represent that just by having this little red dot here, and that's like a line representing that we remember that this subclass is inherited from that superclass. And then we of course have instances. So you might have an instance, and let's suppose that this instance is of the subclass. And I have this blue dot here to represent that Python remembers that that instance is an instance of this subclass. Now, whenever Python is looking for any method or instance variables, it's always first going to look in the instance. So it's first going to look inside of the instance, and it's going to ask, does the instance have that thing? If it doesn't, then it's going to look inside of that instance's class, and it's going to ask, does that instance's class have that instance variable or method? If it doesn't, then it's then going to look into the superclass. And in Python, that's just how superclasses work. By adding this extra layer of looking at the superclass for things that are missing in the subclass, what we do is we inherit everything that the superclass has and more. So this kind of gets to the question of when should we actually inherit from a superclass? Well, you should only inherit if your subclass should have absolutely everything that the superclass has, plus more, or maybe plus some small modification. So let's go over an example of this. So let's suppose that I want to represent books in a library. And let's suppose that we have two kinds of books. We have paper books and we have ebooks. So the way that I would represent that in classes is I would have one superclass for book. So I'd say class book. And every book is going to have a title and an author. So I'll say def underscore init, and that's going to take in a title and an author. And I'm just going to set self.title equals title, self.author equals author. And let's suppose that we have this underscore str method as well. And we're going to return title by author. Okay, so now I have this book class. I can create a new book, so I'll say my book equals a new book. And let's suppose that the title is The Odyssey by Homer. And then if I print out my book, then I'll see that my book is The Odyssey by Homer. Let me actually add quotation marks around this when we print out the book title. Okay, now let's suppose that a library can have two kinds of books. Let's suppose that it can have ebooks and paper books. So both ebooks and paper books have everything that a book has plus more. In the case of a paper book, maybe we have a number of pages. So I'll say class paper book inherits from book. And I'm going to have a constructor that takes in a title, author, and num pages. And then I'm going to call the book constructor. So I'll say book dot underscore init with self, title, and author. Then I'm going to assign an instance variable numPages. So I'll say self.numPages equals numPages. So that's a paper book. Now let's suppose that an electronic book doesn't have pages, but it has a file size, like 3 megabytes, 5 megabytes, hopefully not a gigabyte for a book, but it has some size. So I'll say class ebook inherits from book. So just like a book, an ebook is going to have a title and an author. And I'll say def underscore init underscore self, title, author. And then instead of numPages, it has size. Again, that's going to be the number of megabytes that this ebook takes up. So I'll say book.init with self, title, and author. And I'll say self.size equals size. Okay. So now let's say that my book is an ebook with the Odyssey by Homer, and let's say that it's 2 megabytes. So if I print out my book, then I can see that it's still the Odyssey by Homer. If I print out my book.size, then I can see that it's 2 megabytes. If this is instead a paper book, so let's suppose that I also have a paper copy of this book. My paper book equals new paper book, the Odyssey by Homer, and let's say that it has 500 pages. Then I can see that my paper book dot size, it doesn't have size, instead it has numPages, because paper books don't have a size, they have numPages. So I can see that my paperbook.numPages is 500. So in this example, we wanted to create paperbook and ebook as separate subclasses, because in this case, a paper book has everything that a book has. So in this case, a paper book has a title and an author. And so does ebook. So ebook has everything that a book has. So it has title and author. And paper book also has this additional thing, numPages. And ebook has this additional thing, file size. So that's when you want to inherit, when you want to have a subclass that has everything that the superclass has, plus more. When you don't want to inherit is when you want to contain another class within a class. So let's go through an example. So let's suppose that I don't want these books to exist in isolation. Let's say that I want to have a library class, and libraries are going to contain books. So what I'm going to do is I'm going to say class library. And every library has some fixed number of books. So I'll represent that by saying def init self. And I'm going to say that every library starts off with 0 books. So I'll say self.books is an empty list. And then we can add books to our library catalog. So I'll say def add book, self, and then book. And here, book is going to be an instance of book. So whether it's a book, a paper book, or an ebook, what we do is we add that book to our list of books. So I'll say self.books.append book. And I'll say def get size. This is going to return the number of books that we have. So I'll return the length of self.books. I'll actually give this a clear name, get number of books. Okay. So the important point that I want to highlight here is that even though there's some relationship between library and these book classes, in that a library contains a list of books, we didn't want to inherit from book, or we didn't want book to inherit from library, because it's not that a library has everything that a book has, it doesn't, or that a book has everything a library has, it doesn't either. It's just that libraries contain books. So rather than inheriting from books, I created a separate instance variable to actually contain this list of books that we have. So this is an example of what's called composition. So a library contains or is composed of a list of books, but rather than inheriting from the book class, then we want to have a list of books as our instance variable. So let's see our class in action. So let's suppose that I have the Ann Arbor District Library, AADL, equals a new library. And I say AADL.add book, my book, and AADL.add book, my paper book. Now if I print out AADL.getNum books, then I'm going to see that my district library has 2 books. That's all for now. Until next time.